All right, welcome everyone to this week's community call. This is the second one for the year. We have quite the lineup and quite the topic to discuss. So today we're going to be discussing the recently announced CELESTIA XNYM partnership. We have quite the lineup to do so. First of all, we have Claudia and Max, XNYM Chief Scientist and XNYM Senior DevRel Officer, respectively. How's it going, folks?
Going good, thank you.
Looking forward to the call.
Excellent. Yeah, same here. Same here. This is going to be an exciting one. And we also, of course, have Mustafa, a founder and CEO of CELESTIA, the man himself.
Yeah.
Mustafa.
Good, yeah, looking forward to the call.
Be excellent. Before we get started, let me run through some usual housekeeping items. So big thanks again for everyone who's joining this call. As usual, we're going to be keeping an eye on your questions. So feel free to leave any questions you have in the YouTube or Twitch live chat, or on the XNYM Matrix server in case you want to preserve your privacy and not log in with your YouTube account. You can also leave your questions on the XNYM Matrix server. There is going to be a pull-up, of course, for this call at the end, so stick around for that. And of course, the recording, if you miss the whole call or parts of it, is going to be available on the XNYM YouTube channel. And with all of that said, let's jump right in. So, Mustafa, I'm going to start with you. But before we get into CELESTIA, which literally set the scene for blockchain scaling with its modular architecture, if I can speak, I want to dig through the lore a little bit, because I hear my sources tell me that there's quite a bit of lore going back all the way when it comes to you and XNYM. So I hear that you were a co-founder of Chainspace, along with someone who was also a founder of XNYM, Dave Hirschen. And then, of course, as we know, Chainspace was bought out by Meta for the now failed Libra project. I also hear that you and Harry may go back even further than that to your LulzSec days. So please introduce yourself and share as much or as little as you want from the Mustafa plus XNYM lore.
Sure. My name is Mustafa, co-founder and CEO of CELESTIA Labs. I've known Harry for a while. I think it's been 10 years now. I think we first met in 2015 in a Chinese restaurant in London. And at the time, I think he was working for what's it called? The W3 consortium, which sets standards for the web. And I think at the time I was saying, hey, I thought like he was an evil guy or something, because at the time, like, W3 consortium was getting a lot of controversy for proposing to add DRM technology to the web and to enshrine that into like web browsers and stuff. So I was kind of like questioning him on that, but it turned out like he was the one trying to fight against that within W3C, and trying to like convince Tim Berners-Lee to be against that, to add DRM as a web standard. But and then at the time I mentioned, like I think he had headed me before, because I was previously in this hacker group called LulzSec that had like hacked into a bunch of government agencies and corporations. So then he kind of like had already heard of me, and then I mentioned that I was looking to do a PhD in computer science, focusing on blockchain scaling. And I had actually already applied for a PhD with my advisor, George Nazis at UCL, but he didn't reply. So it turned out like Harry Halpin was actually staying in George Nazis' house, so that he put in a good word for me, and then he replied to my email. And then that's kind of how it started. And then I ended up doing a PhD at UCL, focusing on blockchain layer 1 scaling. And as part of that it's kind of spun out into a project called Chainspace, which was like the first sharded blockchain system, and that was later acquired by Facebook. So George started working on Libra, but now he's part of Sui, which came out of Libra. And but I didn't end up joining the Facebook team, and I instead started CELESTIA, which was another scaling project that I'm happy to go into. And the idea of CELESTIA is basically, at the time, a lot of scaling technologies for blockchains were focusing on trying to do everything at once. What we call like these monolithic systems, like Solana, for example. They're trying to scale the base layer. They're trying to cram all transactions into the base layer as much as possible. Whereas CELESTIA kind of takes the opposite approach, which is like this rollup centric approach, which is that let's make a very minimal base layer that does only the core things that a base layer is supposed to do. as defined in the Bitcoin white paper, which is like a blockchain, it's just a timestamping server. So let's just like create a very efficient blockchain that only does one thing, which is like developers can post arbitrary data onto it. And so it basically all you do is you post the data to the chain, and it makes sure that data is widely available to the internet. And that's the kind of like the only core primitive you need for any developer to build their own blockchain on top in the form of a layer 2 technology. And so this is what we kind of call a modular blockchain, a modular blockchain where the components are separated, where you basically separate execution from consensus, and you're basically allowing developers, instead of forcing developers to use some shared computer or shared execution environment like Solana or Ethereum, instead developers have the freedom to define their own execution environments in the form of rollups, and Celestia just creates a very scalable base layer for that. But the core of that, to make it scalable, is a primitive called data availability sampling, which basically allows. Sorry, feel free to interrupt me if I'm going on too long, but I'm just trying to introduce Celestia.
You're answering all my questions. Go ahead. It's lovely. I can just sit back and listen.
Yeah. So the core technological primitive of Celestia is this idea called data availability sampling. And the idea is that how do we increase the block size of a blockchain network without making it more centralized? Because if you make the block size too big, then it means that end users or normal people or businesses, it's more expensive for them to run a node that verifies all the transactions or verifies all the data in the system. So it's like there's this trade-off between scalability and verifiability. And so we fixed that using a technology called data availability sampling, which basically makes it possible for normal people, whether it's someone running a wallet or a business running a node, to check that all the data on the network was actually correct and was made available. But without having to download and check all that data for themselves, they can just sample and download random pieces of that data. And then if they download random pieces of that data, then they have a very high probability guarantee that the blockchain is actually correct, and is like the validators aren't being malicious. But the problem with that, which this partnership with NIM fixes, is that if the wallets or the nodes are not downloading these pieces from the chain anonymously, then like someone a validator could maliciously target specific nodes in the network by releasing the requested sample to them, but not releasing it to everyone else. So then they could trick those nodes to think that the data is actually available when it's not.
So this is what we call a selective disclosure attack, right? So what are the possible consequences of such an attack?
Well, the consequences are basically that you can, depends on how big the block size is, but it slightly reduces the security of the scheme, because you might be able to trick the first few hundred nodes that sample, because what the validator could do is, like, let's say the block is 4 megabytes and you need 2 megabytes of data to reconstruct that block. The validator might just release just enough data such that such that the block is not reconstructible, but they can trick a few hundred light nodes or users that the data was available and correct. So the consequence is basically that you can trick the first few hundred users that the data is correct when it's not.
Sounds pretty severe. Now moving on to Claudia and Max.
I don't want to over catastrophize it though, because it's still like, it depends. It's like a one of n attack, in the sense like you can only trick a static number of like nodes. It's like if you have 1 million wallets, for example, you can still only trick a few hundred. If that makes sense. But it's obviously not ideal. So for maximum security, you need to prevent that.
Excellent. All right, so moving on to Claudia and Max, because this type of attacks, so selective disclosure attacks, is I guess primarily what our partnership is supposed to solve for or protect against. BIM has this noise generating mixnet, which which is uniquely positioned to solve such a problem. Why is that, and what will the solution look like?
Yeah, and by the way, oh sorry, it's a question for Max, right? Not for me. I'll let you go. Okay.
Yes, Max and Claudia, but you can feel free to add something if you want.
Yeah,
Yeah.
go ahead.
Sure. I suppose I'll start diving in, and then Claudia, you can whenever you want. Yeah. So basically, what we're basically trying to do is, like, we're leveraging the fact that by running traffic through the mixnet, you're disintermediating the IP of the person who's sending any request. In this case, the light node that's running in data availability sampling mode, and actually like kind of requesting these fragments of blocks. And what this actually allows you to do is that instead of this kind of malicious validator saying, okay, well then maybe because all of these sampling requests are coming from a particular IP, and this is the person, one of the few hundred initial nodes that I kind of want to trick, then the node that's getting all of these requests can't tell that this is either the same request or the same IP address itself. So it doesn't really know, in terms of seeing this as like a targeted attack, then there's no way for the malicious validator node to be able to essentially kind of direct that attack at, whatever, a certain IP address or a certain range of IP addresses, because those two things have been disintermediated. All this malicious validator will see is that, oh, okay, well, this is coming from an array of IPs, and maybe you could see that these arrays of IPs were like different kind of exit points from the NIM network, but you don't know where that can originate. So that's
Yeah, so maybe to complement what Max is saying, I mean, what a mixnet really allows you to do is to implement some sort of secret shoppers type of solution, where you prevent attacks that rely on the identity of one of the entities to behave differently, right? Like, it's also the same, like, for example, that in testing mode, a system might be behaving differently than in real mode, and so on, if they are able to distinguish when they're in testing mode and when they're in real mode, right? So in general, I mean, this is one use case, but in general, you have all these attacks where some node either can decide to accept or not accept information depending on the source of the information, right? So for example, if I am sending relaying information for everybody, but for some target users, I censor them and I refuse to send information that is coming from them. Or the opposite, I might refuse to provide information to somebody who's requesting it on the basis of who they are, right? So by removing the possibility of identifying who is asking, now I have to behave in the same way when I receive information from someone, because I don't know who that person is. So I don't know if this is like a target or not a target. And the same, if somebody's asking me for information to provide, I am not able to make a decision based on the identity, right? So this kind of negates this kind of attacks that exploit differential behavior. I mean, Celestia is an excellent example, but it's not the only one. Like all these Eclipse attacks in peer-to-peer networks, they basically rely on this differentiated kind of behavior with respect to different entities, right? So yeah, it's really exciting to see that this capacity of the mixnet to kind of make everybody look the same, and therefore disable any malicious behavior that is selecting some targets and treating them differently.
Right, I feel like Max is about to say something, so I want to give you the floor if you do, unless or otherwise we'll move on to the next question.
No, not at all. There's other stuff to talk about later in terms of what's also exciting about the actual technology in the peer-to-peer context which is happening, but we can talk, that would derail, I think, we can talk about that later on.
What about you, Mustafa? Anything to add there?
Yeah, I think that all makes sense. And one thing I'll add is that like, to make data availability sampling maximally secure, it's not enough just to make the request anonymous. You also have to make them unlinkable. And what that means is that, like, because if you just wanted to make the request anonymous, like, you can't track them you don't know who sent them. That's like pretty easy to do. Like, you can just use Tor or something, right? Like, you can anonymize them easily. Like, there's tools for that. But it's not enough for them just to be anonymous. You also have to make them what's called unlinkable, and to prevent something called traffic analysis. Because, like, if, like, let's say so a user is making 20 requests, they would usually send those requests all at the same time, like let's say within the same second. And then a smart attacker could tell that all of those requests came from the same person because they all were sent at the same time within the same second. So you have to do what's called you have to prevent traffic analysis, and that's you can't just use an anonymization network. You have to specifically use a mixed network, which is what NYM provides, and that's why that's kind of like why we're doing this partnership. But it's also, I also want to add that what we're trying to do here, like Ethereum also is implementing data availability sampling, and so this is going to be a problem for like the next generation of kind of scalable blockchain networks, not just Celestia. But with this partnership, I think we're the first people to kind of explore how it can be actually done, implemented in practice. So this is basically kind of like a cutting edge use case for a mixnet that I think is going to be more important to the foundations of how we actually scale blockchain systems.
Definitely is a good use of the specific tech of the mix that seems to be helping in a very specific way here. Moving on to the next question. Actually, this one I think is mostly for you, Claudia. So you're a bit of an expert, if I do say so myself, on metadata, right? So let's talk about metadata in Web3. So and distributed systems. What kind of metadata leaks do we see in these systems, and what is the impact of those leaks?
Well, I mean, metadata, it really depends on the use case and the information you want to maintain confidential. So, for example, if you have a system where you want that transactions are that you don't know who is initiating a transaction, or whether two transactions have been done by the same entity. So metadata can sometimes help you, even if the cryptography is really nice and is not kind of giving away in an obvious way identities or links between transactions. You can sometimes use metadata to be able to kind of bypass cryptographic protections and use heuristics and probabilistic information on timings and packet sizes and network traffic in general, in order to infer this information that in principle should not be available, right? So, I mean, yeah, metadata is created with any online communication that we have at the network level, right? So it includes, like, whenever we are sending information around, it includes the source and the destination and the number of packets and the sizes of these packets and the all this kind of information that is not really the content, but all the characteristics of how this content is transferred. And the problem is that, yeah, it can be exploited to learn information about who is engaging in transactions, and sometimes even can give away like the actual content of the information, even without breaking the cryptography, right? So I mean, it's the problem is very much at the infrastructure level, right? So this is a problem that affects nearly any application that is run over the internet, over a communication network, in the sense that whenever you have like two entities or processes or whatever that have to exchange information, and you want to have some confidentiality properties on the fact that the information is being exchanged, on the nature of the transaction, or the content of the transaction, then anybody who is able to observe the network and observe the exchange might be able, if you don't have any specific protections, they might be able to just study this information, analyze it, and make inferences that reveal information that should be confidential. So this is where a system like the NYM mixnet comes into play, by making it really hard to do these correlations, in the sense that the first of all, no packet has like source destination available within the packet itself, right? So you go through multiple intermediaries. So that means that if you're able to intercept at one specific point, you only see one chunk of the path, but not like end-to-end communication. And then using cryptography at every step, so that it's difficult to link based on content, but also using mixing, which is goes a step beyond things, solutions such as Tor, which means that the flow of packets coming into each of these intermediaries and the flow of packets coming out are scrambled, they are reordered, and therefore you're not able to do matching on packets on the basis of timing. So I don't know if this is what you were asking, or if you want me to go more in detail on some of these things.
You can always go more in detail on these community calls, so feel free if you want to. But this was a pretty great answer. So up to you.
Okay, I'll leave it at that then. If you want any more
Okay.
details, I can expand.
So it sounds like it is a pretty good assumption on my side that that this can be used or so that the mixnet and its properties can be used for other blockchains in various different applications. So that brings me to my next question, because throw back to our previous community call, Max, where I brought you on to talk about work on our SDKs and how integrations will work in the future. Right now, NIM is heavily pushing the VPN, of course, which is coming out very soon. But guys, let's not forget that NIM is a general purpose network, which brings these properties to any blockchain, right? So I just wanted to ask you, this R&D that we're doing with CELESTIA, what kind of opportunities will that open in the future for the NIM network to become this general purpose secure routing protocol that it was meant to be?
Yeah, I think there's two kind of like major points that immediately jump out with this. One is actually the fact that CELESTIA is also kind of building on and using for the networking of all of its nodes, is already using itself like a standardized modular networking library, which is libp2p. Then that's very exciting, because of this work that we're doing here with CELESTIA actually also might be the start of trying to standardize something like a NIM transport that could be used by other projects who use libp2p, right? So it's kind of like this could be the beginning of also then standardizing and modularizing how other projects can far more seamlessly kind of like pull NIM in deep into their networking stack. So you make it a lot easier for developers to pick a particular mode and then not really have to think about the I suppose the intricacies or the different way that the mixnet actually sends traffic compared to something like something a lot more standardized, like say, I don't know, if I want to pick between TCP and UDP, then I'll kind of get like people already know what these interfaces look like, and it's quite easy for people to kind of drop stuff in, right? So there's that. So it's kind of the opportunity in terms of how this development could actually then be kind of pushed back deeper into networking libraries that other people use. And the second thing that I'm also quite excited about with this is that this is the first time, I think there's a lot of interesting potential there to look into with regards to how the anonymous replies in NIM work. So we have these anonymous replies with these things called SERBs, so single-use reply blocks, which is where I can dial out to a peer and I can send them a request, and with that request, I also send a bunch of pre-computed like headers for Sphinx packets, which you can think of like analogously as just like pre-addressed envelopes, right? So that means that the peer that I'm actually dialing out to with my request, in this instance, it would be this particular request for a certain part of a block to verify that actually it's there and it's live. Then the peer can reply to me without actually knowing my NIM address as well, right? So this is going to be quite interesting in the peer-to-peer context, where usually you have this like symmetrical relationship in terms of, well, the peer is dialing me and I have to know their address to reply to them. So that's also going to be quite interesting to see how that like plays out, both with this, but also in the broader context of like how we can integrate SERBs and peer-to-peer context, where you have a lot of like pinging and usually peers kind of at least know the people around them kind of thing. So yeah, those are the two. Both of those things individually are pretty exciting, but we have two of them at the same time, which is wicked.
Sorry, guys, I was muted. So a follow-up to all of you, actually. Do you see any like high-value targets for such an integration? So after CELESTIA, what should be the next announcement of partnerships, just based on the technicals and where it would help the most to have a mixed integration?
I mean, from my perspective, there's some like pretty cool. I can't speak for other projects, but on CELESTIA as well. But there's some pretty cool like privacy stuff on CELESTIA. So one of the projects on CELESTIA that I'm excited about is a like project called Pay, Payy, and what they've developed is like a really clean interface for payments. Like you can easily you can go and install the app, and like you can pay your friends very easily. It's like the best user experience for crypto payments I've ever seen with stablecoins. but the unique thing about them is that they do like privacy preserving payments. So when you send the payment, it's like no one else can trace it on the chain because it's like they use ZK cryptography. But obviously, to enhance that privacy, they might at some point they might want to add like some kind of mixnet like NYM to make sure that it's also anonymous on a networking level as well, not just on an on-chain level.
Okay, can you please spell the name again so we can find a link to it and drop it? It sounds like a very interesting project.
I'll drop it in the chat in a second.
Oh, amazing! Thank you.
It's payy.link. There you go.
Oh, amazing. We'll share it. Thank you very much. What about you, Max? Any particular targets?
There's a couple that I suppose I could bring up. One of them is actually also something that's built using Celestia, which is called Prism, which they're looking at how you can do like properly authenticated end-to-end encryption, and so kind of removing the need for having like certificate authorities or having to like trust that the public key that you're getting to verify something from whoever's servers, like Signal, WhatsApp, Telegram, whatever, is actually legit. I particularly like that because again, it's just kind of like slotting this tech very deep down into the kind of the net or the blocks that are building up all of this like secure infrastructure, and just doing it in this very clean way, which I particularly like. But also, kind of going back to the libp2p point. I mean, if we can kind of get it into there, or at least have the beginnings of standardization with that, then libp2p becomes an IPFS, right? It was originally their networking stack that they then kind of spun out into its own thing, and then that's also kind of like Filecoin. The Ethereum validator consensus algorithm also uses libp2p for its networking, so like that's kind of an enormous open field where you could kind of like pull this stuff into.
Yeah, I mean, it's a general building block, right? Like almost any application today needs networking, and if they have any security or privacy property that they want to provide, I mean, both in Web3 and beyond, right? Like,
very
one of
much
the very interesting use cases is messaging systems such as Signal, for example, where, I mean, sure, we have end-to-end encryption, so the confidentiality of the content is protected. But the graph of who talks to whom, this is incredibly valuable, right? Like it gives you even kind of the big dynamics of communities, of the nature of relationships and so on. So to me, that's, for example, a very exciting case, even if it's a use case, even if it's not Web3. So I agree that it's great if we can kind of standardize as a building block so that any application that wishes to improve the network privacy can simply, integrate with NYM and be able to offer this higher level of privacy protection at the network level.
There were quite a few pretty awesome projects listed there. So who knows who pops up on one of the NYM community calls coming up this year. With all of that said, we actually blazed through all of my questions pretty quickly, but I have a last one for you, Mustafa, which is, just to wrap up, any other thoughts that you want to share? And also, I wanted to ask you about the future of Celestia, and also modular chains in general. What should we be excited about? What should people keep an eye out for? What does the future hold for Celestia these days?
Yeah, I mean, I think from a product perspective, the aim of Celestia is to make it possible to build stuff that just aren't possible on like shared smart contract chains like Solana or Ethereum L1, for example. Because like there's a lot of like use cases that people want to build in crypto that just aren't doable if you're sharing a computation environment with someone else. And some of the projects are already been mentioned here. But I mentioned Pay, for example, which is a privacy-preserving payments app that uses ZK cryptography to make the payments private. That has a very good user experience. Like that wouldn't be possible on a shared smart contract environment because, like for example, like the ZK would just be too expensive to do on a shared smart contract environment, and the opcodes aren't there. Or like Prism, as Max mentioned, is another cool example. And there's like a bunch of rollups on Celestia, like Orderly, for example, which is a perp, like a low latency, high throughput perp DEX that can only be done as an L2 because on L1 the latency, for example, will be too high. So that's kind of like what, and I think we have a lot more chains lined up in the pipeline that do things like that. So that's one thing that I think to keep an eye on, to keep an eye out on.
Anything lazy coming?
Well, I've heard that Daisy Chain is coming. So we have like a NFT community called that has like a sloth NFT community on Celestia, and they're developing a lazy chain on Celestia. I don't know. I hope it has very slow block times.
They are. I have to confirm this, guys. I'm sending a link in chat. The Celestine Sloth Society is a really dope meme, or sorry, not meme, NFT community. So make sure to check them out. Really dope NFTs, really dope community. What I meant by lazy is, of course, the lazy UX, the lazy builder experience, and all of that stuff. I really enjoyed that narrative. I think it's much needed in the crypto space. So yeah, just keep building away, because this is some incredibly crucial stuff. Interoperability and modularity is actually, I think, probably like one of the few very strong and very necessary narratives right now in the entire space. Max, once again, maybe I'm misreading you, but it looks like you want to add something there. We have quite the time, so feel free.
I was just nodding along. I was going through, looking at some of the questions, and yeah, just nodding along basically. But yeah, I suppose to echo kind of what I suppose what Claudia said before, then like I think both projects are building blocks that will just kind of accelerate the ease with which people can start building kind of meaningful applications on top of everything. And I think this, especially the kind of like all of the stuff in recent years with Celestia-based rollups, the sovereign rollup model, all of this stuff, I think we're kind of also getting to the point where you don't have to start rolling out your own infrastructure at all. Or we kind of went from Ethereum, we had monolithic chains, we had Cosmos as a network of monolithic chains that could all intercommunicate with IBC, and then it's just there's smaller and smaller building blocks that you as a dev have to do, because there's an increasing amount of standardized chunks already there that will allow you to kind of drop things in and out. That's
I think one thing that would be, I don't know if you guys are already building this, but I think one thing that would be helpful. It's like, so you guys like launched like a NIM VPN, and with NIM VPN, or with NIM in general, the original model is that users can pay to access the mainnet, like presumably with NIM tokens. But we kind of like, we need a reverse of that, or like a reverse VPN kind of thing, where like let's say I have an app, like Celestia is an example of that, or like if you, let's suppose you have an app and you want your users to connect to it anonymously using a mixnet. Like, can you integrate like a name library to your app, so then the users connect to your app anonymously, but instead of the users paying for the bandwidth, the app pays for the bandwidth, like an ISP, and then have some kind of like have some kind of like inbuilt DRS resistant, so that a single user can't just like consume all of the credits of the app.
Yeah, we are already working on something basically like that. So looking at this functionality, especially in terms of like how you get this functionality into the SDKs, right? So there's a lot of plans and in progress stuff to do essentially that, because I think that is the next step. And in the same way that you have very cool swap abstractions in blockchain projects now, where like I can kind of I don't have to then kind of like fund a wallet, because you have like an implicit swap thing happening that will allow you to like whatever implicitly swap from the native token of a rollup into tier or something like that. Then yeah, we are working on a similar thing where you could theoretically have something that's using the NIM SDK, but I, as an end user of whatever secure messaging app, never really has to know, or never really has to like interact with the token in terms of payment, and the kind of the credentialing system as well. So we are, that's very much like in flight already.
Yeah, I mean, it's very important to reduce friction, right? To be able to facilitate integrations and not expect end users to handle a lot of complexity of having tens of tokens, different things to pay for each different thing, right? Like, so yeah, definitely that's some part of the roadmap, as Max is saying.
Yeah, because I mean, we need it just to get the base level anonymity set anyway, right? Like there's, and I think a lot of other privacy tech has also, but also I think in general, we can also see this in like broader blockchain adoption as well. If there is that friction, then you're kind of the group of people who are like willing to then use that and do that does, or rather with the less friction, then the amount of people who this becomes open to. I think a lot of people would like to use the secure messaging app, but a lot of people, I don't know, don't want to use PGP because it's kind of clunky and gnarly to use or something like this, right? It's like these barriers also stop something scaling. Whereas actually we can, with this, being able to, I suppose, like have, to remove the need for the individual user to actually kind of like interact with the payment system and the credential system and everything, and have that kind of be like side channeled to them by the people running an application, or through some other mean, maybe like a community pool of stuff that you can also download stuff from. Then you're opening that up to like magnitudes more people.
Mustafa, anything to add there?
No, I think that makes sense. I look forward to that.
Yeah, I just wanted to add that, or I guess reinforce that abstraction, I think, definitely seems to be the way forward for the space in general. PGP is a great example. It's solid technology. A bunch of people, enthusiasts, and those who really need it, still use it to this day. But you don't see mass adoption because because it's just way too complicated for the average user. So having similar level privacy protections built right in without you even having to know about them is definitely the way to go to move forward for us towards privacy, or towards just the adoption of blockchain technology in general. All right. With that said, we could jump into the community questions. What do you guys say? All right. So first up, this one is from Pierre. Will NIM use a TIA's DA? DA being probably a data availability layer, I think. That's what they're referring to. Max, maybe this is a question for you.
So I suppose by NIM, then maybe the question is actually regarding NIX in terms of like our own blockchain infrastructure, because that would be the only instance where I could see that, where you kind of have the generalized data availability problem. Definitely something to look into, like folding back into NIX somehow, I suppose, but I'm also not 100% sure I understand the question completely, to be honest. Sorry, not.
Well, I mean, the partnership isn't about NIM using Celestia for DA. It's about Celestia using NIM's mixnet for its DA. But I guess the question is, actually, I don't know how like what like NIM is a Cosmos SDK chain, right?
Yep, pretty standard Cosmos SDK, Cosmos enabled. Yeah.
Yeah, I mean, this is like a different question, but like, what like, as far as I understand, like the NIM blockchain is basically like kind of like an orchestration layer for the nodes, and you can like, and a payment system for nodes. Like you could definitely imagine. Actually, it's a good use case for a rollup. Like, instead of being an L1, like, and there's several advantages for a system like that to be a rollup. This is the L1. For example, like you don't have to. You don't have to you don't have to mint new tokens or have inflation to pay the validators, for example. Like if you're a rollup. So there's like, so I mean, it could be a good use case to be a rollup in the future. But it's also not, it's not what this specific announcement is about.
No, but yeah, you are right. I mean, it is the way, because the way that we use NIX exactly is, we negated certain problems in terms of having like centralized directories that you could DOS or block access to by having essentially the network topology of the directory being in a smart contract. This is also obviously how we do all the rewards and everything, and then with the credentialing system as well. Then like this is where the the consensus between certain members of the validators who also engage in like generating and verifying obviously chunks of the selective disclosure credentials. That all lives, but yeah, that could that could live on the road quite easily as well.
Because like the point of NYM is not the point of NYM is not to be a blockchain. The point of NYM is a mixnet, but you have to you need a blockchain to orchestrate that. And like in a different world, like you could have, if Ethereum was more versatile, then you could have just been a smart contract in Ethereum, right? But that's not possible. So you have to create your own chain.
Absolutely. I mean, the reason we have our own chain is out of necessity, right? It was not our. It's a necessity that we have this building block for having a consistent view on the network, so that everybody has the same information and everybody agrees with what are the nodes, what are the keys, and all of these things. Indeed, I mean, if we were starting today to build things, maybe we would have piggybacked on some existing system instead of having to have our own, right?
Yeah, I mean, it's exactly what Celestia was built for.
Yeah, exactly. I mean,
definitely a lot has changed since NYM launched, right? Including Celestia popping up. Sorry, Claudia, I cut you off.
Yeah. That was my point. I mean, the things happened in a certain time when Celestia was not around, so we had to solve the problem that we had. But the solution maybe would be different if we would do it today.
Yeah, bootstrapping our own Cosmos SDK chain was the easiest solution at the time, and I mean that was also not very long ago, like a matter of years. And then now actually you can see that like that's so much more of a monolithic solution than the possibilities that are like around what 2.5, 3 years later. Not even
but that was I think that was 3 years ago, which is at least 20 years, 5 years ago. So that's around 100 years in crypto years.
Yeah.
So
5.5 actually. So
5.5. That's 105 or 110 years. I lost my math. Anyways, next up is the big one, Mustafa. I hope you're ready for this one.
Okay.
Is Mustafa using NYM VPN from Jason? Is he?
I'm not at the moment right now. I actually have right now. I have my own personal VPN that I set up on my own server, but and sometimes I use NordVPN if I need geographic access. But I'm definitely going to try NYM VPN. I did want to try it a while ago, but it only recently launched, so now is my opportunity to try it.
Not launched yet, actually. It's gonna only launch fully commercially launch on the 13th of March, which is really good because you can try it for free until then. So it's all free.
Okay.
And it actually works.
Yeah. There's a lot of work went into it over the past year or so. Yeah.
Okay. Well, maybe you can give me an early alpha tester, beta tester role.
Not needed anymore, but just for the props, we can actually give you the beta tester role.
Okay.
All right. So next up is from Rocio. Thanks for another great question, Rocio. What would you tell someone who does not know about NYM to learn about NYM's technology? I guess this is mostly for Max and Claudia, but it will be interesting to hear an answer from Mustafa as well.
To learn about NYM technology. So, I mean, first I will tell them that NYM is really about network security and privacy, right? So that's kind of the big scope of things. It's not so much about, blockchains and things. Blockchains is something we use as a component, but it's really about network privacy. Then, I mean, there is a whole literature, both in academia and outside of it, on network security and privacy and different ways in which this can be approached. It's actually not a very easy problem to solve. So what would I tell them that if they don't know? I will tell them that, that when we communicate through digital networks, we leave traces. These traces reveal a lot of information about us, and if we want to prevent this from happening, we need to have some additional security properties that go beyond end-to-end encryption. And these kind of solutions, like NYM, is kind of best in class, I would say, for this family of solutions. So that I would kind of scope it so that they understand at least what the purpose of the system is and what it's trying to achieve. If they don't know that, then it's going to be difficult to explain all the complexity that comes after to explain how the solution actually works.
Wait a second. The only unbiased person, somewhat unbiased person in the room is actually Mustafa. So how do you feel about the Claudia statement that it's best in class, the NIM network?
Well, I think Claudia is a well-renowned expert in mixed nets. So like people have been trying to build mixed nets since the late 90s, and I don't really know of any live mixed nets other than NIM, to be honest. So I don't think it's the best. It's only the best in class, but it's like it's the only live mixed net I know of that has any kind of traction. Well, I'm sure there's some others, but like
Yeah, there's
but I haven't. Yeah,
prototypes. There is
yeah.
it's actually a kind of hard system to build. So that there is one system that actually was deployed and lived and might still be around, which is Mixmaster. This was made in the 90s, so it's a pretty old technology by now. And it was it was for email exclusively. It was a remailer. So yeah, that network was there, but I mean, of course, you had no guarantee of delivery, so your email might get lost. I think the kind of latency to get to route through this network was like in hours. So it's kind of a, yeah, compared to a NIM, I think it's not such a usable kind of system. And then the others that are proposed, some of them are just academic proposals with maybe some little research implementation for proving certain aspects, but not full-fledged systems. This is pretty hard to build. I mean, I think the only comparable is Tor, which is not a mixnet. It's a different kind of system. And even Tor is not quite as complex because it doesn't have like a token and a whole credential system and an economic system on top of it. It's just a subset of it simplifies a lot of these problems, right? So yeah, I mean, pulling off building a mixnet is not an easy task. I think that's why we have been so busy for the last 5 years.
Believe us, we know.
Yeah. Yeah, that's what I
All right.
mean. It's the only full-fledged. People are building like experiments for mixed nets since like the 2000s, but it's the only like full-fledged system at the scale that I know of.
Yeah.
I mean, there's also mixnets. Now I should give the complete story. So there is also like some implementations that are very specific applications. So Mixmaster is for email, and there is a specific mixnet. We have different properties for voting, right? But this is like basically only for voting. So you want to organize an election. For example, you have a university and they want to select the rector or president of the university, right? And you organize a voting. So some systems, and actually the project that gave birth to NIM, which is this Panoramics project, was a European Union funded project. One of the use cases we were looking into was voting, and one of the partners was kind of commercially deploying voting mixed nets in Greece. This is a different system because, again, like you basically every person can only send one message. The messages are all the same size because it's just one vote and it's a very standardized. You can prove that is well formed and all of that. You can wait for hours until you collect everything. So this is not something that you can use for then Signal or Celestia, block availability sampling or all these other use cases. It's just very custom made for something like voting.
But it's really cool nonetheless. So I never heard about it. Maybe if you could drop a link to it, we can share it also in the chat, and I can read up myself, Claudia.
Yeah, I can try. I'll look for the organization that was doing this. Hopefully I'll look for it.
Thank you so much. Next up, question is from our beloved writer, Casey Ford. And this one is for Mustafa. So how do you anticipate routing queries through the mixed net will affect chain performance compared to before integration?
Yeah, I mean, it's definitely a trade-off because obviously if you route something through a mixed net, like there's definitely a latency trade-off, a trade-off between latency and how anonymous you want to be, because if you want to be fully anonymous, then you need to insert a lot of dummy traffic and insert a lot of delays, and that's like something we want to minimize, obviously, for the sampling to happen as fast as possible. So that's something that we need to work. That trade-off is like that's trade-off like something that has to be tuned as part of this integration work. And like we have to find also a reasonable compromise so that like we delay traffic a bit, but it doesn't affect the end user experience too much.
Thanks for that answer. Next up, I think we mostly answered this at various points of the call, but I will still ask. This one is from Anderson. Thanks for the great question. How will the NIM mixnet improve Celestia's network, and is it expected to have any impact on the token economics of each token?
Yeah, I mean, I think as we discussed at the start, the NIM mixnet improves the Celestia network by improving the security of people running wallets on the network, to make it possible for us to increase the block size without sacrificing end user decentralization and scalability, by making it possible to do secure data availability sampling. I don't think it has any direct impact on the tokenomics of Celestia, but maybe, yeah.
I mean, for NIM, obviously, anonymity loves company, as we have said many times, and having like a whole class of entities come and route through the network is improving the anonymity set for everybody. So there is a great for NIM to have all the Celestia traffic being routed. And I mean, the value of the NIM token is going to be, in a way, linked to the usage of the VPN, in the sense that more demand for routing traffic to the network is going to trigger more demand for the token because of how things are structured, in which, NIM tokens are kind of bought from the market when the network gets, when people are buying access. So yeah, I mean, demand will be good for the NIM token, because that's how it that's how it has an organic kind of value.
Yeah, absolutely. So, well, I don't think there's a big token economic impact on NIM, but there's definitely, so not only, just like Claudia said, NIM or the NIM mixnet benefits from a larger and more diverse anonymity set, but all, like, each and every one of its users as well. So the more the larger number and more types of stuff your communications are mixed in with, the more private you are. So this is the more types of things we can put on the mixnet, the better, basically, simply put. All right, thanks for the answers, guys. And also thanks for the question. Moving on to the next one. This one is also from Rocio. Is the Celestia and NIM integration ready? If not, when will it be ready?
No, we are in this initial stage that we're doing right now. So we're spending quite a lot of time looking at the different architecturals, how we would architect these kind of solutions to enable this differently, and what they would give. This is the second kind of like major integration that NIM has done. So it's also very much a chance for us to think through the problems in the real world setting of, kind of like the kind of like this kind of way of abstracting away from users of a thing that's using NIM, that they have to kind of like get the anonymous credentials, they would have to get NIM tokens, looking at how we would be able to build that, and looking at the different solutions that are in front of us in terms of, where in the stack we're actually kind of like putting these two libraries, how we're going to approach, we're kind of just starting to approach looking at how we would maybe have something that's used to running P2P, like have a NIM transport with this. So we're in the we're in the early stages with that right now. In terms of when it will be ready, I will default to, actually, no, I won't even default to soon TM, because it probably won't be that soon, but it will be happening. So it'll be worth the wait, is the only answer.
When it's ready.
Yeah, when it's ready.
Guys, once again, I would like to point you to that previous community call that we did with Max, where we did a bit of a deep dive into integrations and how they work and all of that stuff. So if you're interested in what goes into such R&D that we're currently doing with Celestia, then make sure to check that out. Sorry, Claudia, it looks like you also wanted to say something.
No, I just found the link to this mixnet based voting system. It's the Zeus, it's called. So if people are interested, they have a link there and they can dig more on how this works.
Yep, so it was dropped in chat. You can see it there, both on Twitch and on YouTube, if you're interested. Mustafa, I can't see your face that well, so I can't tell if you are also about to add something. So stop me at any point and interject.
I don't know, nothing in mind.
All right. Thanks for the answer, guys, and also thanks for another great question, Rocio. Next up is from Sala. I don't understand what seed or sede means in this
It means the
context.
headquarters.
Okay. All right. So the headquarters. So NIM is based in Switzerland or another country. NIM is based in Switzerland, so we're a Swiss company, and we also have a presence in France and England, to my knowledge. That's it, right? That's where we have like legal entities.
But we
Am I
are
right, guys?
everywhere.
Yeah, in terms of the
We are
legal
absolutely
entities, yes, but we're kind of yeah,
We are all over Europe. I think we cover, if not all European countries.
I think basically every
We're
European
close,
country
maybe even
we're in.
Luxembourg.
Yes.
Actually, let's do a round if you guys don't mind. You don't have to share, but if you want, you can share where you are. I'm in Hungary right now. Where are you, Claudia?
I'm in Belgium.
Belgium?
In the UK, but usually Austria.
Yeah.
I'm anonymous.
So that's your three. Anonymous, local, like location.
Anonymous
I
location.
don't know how to say. Yeah, anonymous location. All right, so yeah, that's just three people from the NIM team. You can imagine how many more countries we could list if there were more people. We're absolutely everywhere. All right, next up is the last question, actually, and this one is to Claudia from Rocio once again. Claudia, when a call about NIM token economics?
I don't know. You should ask that to Sudo when he's going to invite me.
Should we do one, Rocio? It's I'm super happy to do one. Were there any major updates recently to our token economics?
Maybe let's wait until the dev team has finalized the ticket-based rewarding, and then I think it might be interesting to explain to everyone how it works. I think I might have done it preview some time ago when we were deciding on the system, but yeah, we can do a new one once it's launched, so that everybody understands what the logic is.
Yep. All right. I'm always happy to have Claudia on. So, Rocio, you heard it here first. Soon TM at some point in the very near future. And that brings us to the end of the community questions and also the end of the call. I want to thank you all for coming on. This was a really interesting conversation. I can't wait to see the CELESTIA and NIM partnership going live. And I'm also really happy that NIM can actually contribute to CELESTIA's success in this way. So this is some really exciting stuff. Thanks again for finding the time to come on. Any closing remarks from any of you?
Pleasure to talk to Mustafa and to see this rolling. Thank you for inviting us for this community call so we can share with everyone.
Yeah, likewise.
All right. Last thing that remains, guys, as you know, it's a tradition here on NIM community calls that we give you guys a pull-up when the call is over. So we'll do that now. Sandra, can you maybe drop the chat, drop the link, please, in the chat? So you have to go to nim.com/go/pull-up, and you have to enter the secret phrase, which is, drum roll, selective disclosure. Yes, because that's highly relevant to the call. If you remember, the NIM mixed is going to protect the CELESTIA network from selective disclosure attacks. Once again, a huge thanks for joining my dear guests, and also for the community for listening in. See you guys next time. Bye, everyone.
Bye.